I think we all would agree that there is no better way to strengthen a concept in our heads better than a practical example, right? And that is what you and I are going to do. Let's start by opening an application. If the application does not require any network communication, like Minesweeper, we do not refer to the OSI model at all because it's within your machine and stays there. We only refer to the OSI model when the stuff we're doing on our application requires communication outside the machine. That could be another machine or server in our local area network or outside to the internet. All browsers do that, so let's open one and visit a website. What we see here is the result of what we've described in previous videos as communication flow between two computers. And a lot of it happened. Mainly, what happened is that we've sent an HTTPS request to this website. If we go to developer tools or whatever it's called in your browser, you can see the actual response that we've got from the server, which doesn't make any sense to us. The elements responsible for presenting this into readable text and images lives within the browser. The reason why some websites look different depending on the browser we're using is because those elements are not handled the same way. Where do you think those elements that are responsible for presentation live in regard to the OSI model? If you're like obviously presentation layer, you're absolutely right. You see what I meant by the name would make sense in the previous videos? Here are some of the standards that exists within the presentation layer. Encryption and compression also happens in this layer. What about the application layer? The name here can be a bit misleading because of the common use of the word application. It does not mean that the whole application sits there. No. It's rather the protocols that are used for the service we want. In our case, it was HTTPS, and we've used DNS as well, which we needed to translate this website to an IP address. There are numerous application-specific protocols in this layer for file transfer, mail transfer, etc. Comma here, I do care about punctuation because it saves lives. Let's eat grandma, it's not the same as let's eat grandma, right? Okay, session layer. The main stuff that happens here is establishing, maintaining, and terminating a session and takes care of authentication and authorization. For example, Facebook needs to verify that you are who you say you are by asking email and password. Let's pretend that I'm somebody else. I bet someone somewhere is using potato as a name. Oh, try potatoes. There you go, a hit. This information and photos that we see here are public. However, if we try to see, for example, his friends, it wouldn't let us because the session we've established isn't authorized to do so. And that is what authentication/authorization is. And it's happening within the session layer. Oh, also the dialog discipline is decided here too. And that is whether to use half duplex, full duplex, simplex. We'll discuss these later in the series in greater details. If you are developing an app, you need to decide how the data is transported across. Mainly, you got two choices, reliable or unreliable. And you might think that reliable sounds better, but that is not always the case. For example, if you're watching Netflix or on a call, you don't really want reliability, because if a packet gets dropped, the stream will be stopped and the packet will be resent later, which will cause delays and inevitably frustration will follow. But if you're doing a bank transfer, you'd obviously choose reliable. The main protocols used to make that decision are TCP and UDP. TCP represents reliable, UDP unreliable. There are other which we'll look at when necessary. Each application layer protocol uses one of these in the transport layer, sometimes both if necessary, like DNS and SNMP. And they use a well-known port as well, 80 for HTTP, 23 for Telnet, 20 and 21 for FTP, 69 for TFTP. We'll discuss ports later. To see this in action, if we visit a website, let's say news.com, and type netstat, in the command prompt, which works on Linux too, you'd see the connections that we've made. Even though it's one website, we see many connections because the stuff within it sits in different servers. So what happened is that we've hit one server and it said you actually need to get the stuff from multiple other places. That's why sometimes you get random ads about how to become a millionaire overnight and about that prince who wants to leave you his inheritance, etc. So this local address is the equivalent of the source in our diagram, and foreign address is the destination. TCP is the transport protocol, HTTPS is the application protocol. Okay, TCP and UDP determine how the data is transported, therefore they live in the transport layer. Let's summarize this so it doesn't get lengthier than it already is. We've looked at some of the common protocols that operates on the application layer, and we've mentioned their corresponding transport protocol. We've pointed out how the browser and the operating system in this case takes care of the upper layers. In the next video we'll go through the remaining layers, especially the second and the third, so don't forget to hit that subscribe button, and thank you for viewing.